Hello everyone, in this presentation we're going to be covering specifically the axial musculatures, which will include the muscles of the head and neck. With regards to the two categories that we're going to cover, we can break them down even further. So the muscles that belong to the head can be broken down into muscles of facial expression, muscles of mastication or chewing, and the extraocular muscles, the muscles that will be on the outside of the eye. Then we have for muscles of the neck, the muscles that will help with swallowing and speaking, and the muscles that will help to move the head. Let's start with the muscles for facial expression, and many of these muscles they will insert into the skin that's going to be surrounding either the eyelids, the nose, the mouth, and they will produce what we call facial expressions by moving the skin rather than the bones. When we get to the muscles of the appendicular, they will go from bone to bone, crossing a joint. But facial muscles, they usually will insert on the skin, and as we know, they will pull towards the origin. So if they insert on the skin and pull towards the origin, this means that the skin is what will be moving, and therefore you produce the facial expressions. Among the muscles in this group are the ones that will be surrounding the openings of the head, such as the eyes and the mouth. And these muscles, they will function as sphincters, which will close the orifices or the openings, and the dilators, which will dilate or open the orifices. For example, the orbicularis oculi, which is the muscle that closes the eye. So orbicularis for going around in orbits, and oculi for the eye. And don't get this one confused with the orbicularis oris, which will go around the mouth. So this would be your orbicularis oris, and this is your orbicularis oculi. And both of them function to close. There are other muscles that function to open. For example, in the eye, you're going to have what we call the levator palpebrae superioris, which will function to open the eye. But we won't cover this in our lecture. Then we come to the occipitofrontalis, which is sort of an unusual muscle in this group because it is made up of two parts. There's going to be the anterior part, which is this one right over here, which is called the frontal belly or the frontalis, which is going to be just superficial to the frontal bone, as we can see right over here. And the posterior part is going to be called the occipital belly of the occipitofrontalis or the occipitalis, which is going to be superficial to the occipital bone. And these two muscular portions of the occipitofrontalis, they're going to be held together by a strong aponeurosis that's called epicranial aponeurosis, which is this sheet-like tendon that's located on top of the cranium, so epicranial aponeurosis. The buccinator muscle will form the major muscular portion of the cheek, and this muscle is named this way because it compresses the cheeks, and bu means cheek. An example would be, for example, a musician playing the trumpet. They're blowing on the trumpet, so this would be action of the buccinator. It also functions, for example, for whistling or blowing or sucking, and also it will assist a little bit in chewing. Then we can go on to the levator labii superioris, which will originate on the maxilla and insert on the orbicularis oris, as we can see over here, and therefore when it contracts, it will raise the upper lip, just like the name says, elevates the superior part of the lip. The zygomaticus, there's two parts, there's a major and a minor, and both will originate, like the name says, on the zygomatic bone, and both will insert on the mouth. However, you can see that the major is below, so when it pulls on the lips, it will draw the lip laterally, therefore helping you to smile. And the minor, since it is situated superiorly, it will raise the upper lip a little bit. Just because they're situated in different locations, they have slightly different functions. The platysma, it will originate on the chest, which part of it is going to be on the pectoralis major, which we will see later on, and it will insert on the mandible. Therefore, when you contract this muscle, it brings your jaw down, depressing the mandible. The depressor anguli oris, it will originate on the mandible and insert on the mouth at an angle, as you can see over here. Once it contracts, it will depress the lower lip, and therefore it makes you frown. This model is the model that we're going to be using for the lab, and I just wanted to make sure that we go over here in the lecture as well so that you know what parts to look for on the model. Right over here, going around the eye would be your orbicularis oculi, and going around the lips will be your orbicularis oris. Then this would be your occipitofrontalis, the frontal part of the occipitofrontalis, but we will just always refer to the whole name of the muscle. So this is your occipitofrontalis. Then over here, we can see how this muscle comes over here in an angle. This would be your depressor anguli oris, because it depresses on an angle in the oris part, the mouth. Over here would be your levator labii superioris, and we can see it on both sides, so it elevates the lip. Here would be your zygomaticus, that both of them are here. It's a little bit hard to see, but on this image we can see that there's a line here dividing the two. So the top one would be the minor, the bottom one would be the major, but for the lab we'll just consider this to be the zygomaticus. And then laterally over here, with the fibers going in this direction, will be the buccinator. And there are other muscles on this model that we need to know, but as we move on, I'll let you know which are the muscles that we're adding to this model. Here on a lateral view, we can also see the same muscles that we were seeing on the previous slide, but in addition, we can definitely see the occipital part of the occipitofrontalis. This muscle will originate on the occipital part. Like the name says, it will originate on the occipital bone and will insert on the frontal bone. So it spans all the way around. And therefore, if it inserts over here, it will actually pull the muscle and elevate your eyebrows. So that's the function of the occipitofrontalis. Here you have your orbicularis oculi, orbicularis oris, your depressor anguli oris. This would be your buccinator back here. These would be your zygomaticus. Here we can see your levator labii superioris. And we can also see the platysma right over here. On the lab model, same thing will apply. You can see the occipitofrontalis here on the lateral view. This would be your orbicularis oculi. We can see a little bit of the orbicularis oris, a little bit of the levator labii superioris, but on this image we can see the buccinator a little bit better. See how the fibers are going transverse? So this would be your buccinator. We can't see on this view the posterior part of the occipitofrontalis, but we will be able to see it on a posterior view. In addition, we can see the zygomaticus, the major and the minor. I love these images because it shows you exactly the function of each of the muscles when you have a facial expression. So like the name says, the occipitofrontalis will originate on the occipital bone and insert on the skin in the frontal part, and therefore you can see how it will elevate your eyebrows or frown your forehead. The buccinator and the orbicularis oris, they will help with the movement of blowing and also of sucking and closing your lips. The levator labii superioris will elevate your lips, and the depressor, which we don't cover, will bring your lips down. The orbicularis oris will close your mouth, the same thing as we were seeing over here. The platysma, it will pull your mandible down. The orbicularis oculi closes your eye. The zygomaticus, the major, pulls your lips in this direction, and the minor elevates your lips. And the depressor anguli oris, it makes you frown because it brings your lips down. Moving on, we have very powerful muscles that will help with mastication. There are two muscles that will help to close your mouth, which are the masseter and the temporalis. We can see the temporalis will be located right over here on the temporal bone, and the masseter is this big, powerful muscle right over here, located laterally. And the buccinator will also be important for mastication because it will have a function on the cheeks, and therefore it compresses the cheeks against the teeth and the lips, and this will help to break up the food. So that's how the buccinator, which we can see right over here, is going to be important for mastication. And because these muscles, they close your mouth, therefore they will move in this direction. On the lab model, we can see the temporalis right over here on the temporal bone, and this muscle over here will be your masseter on this animation as well. This would be your temporalis, and this will be your masseter, and I will now insert the animation here for us to see. We can clearly see that when the masseter contracts, it pulls the mandible up and therefore closes the mouth. Next, we're going to be talking about the extrinsic eye muscles and muscles that move the eyeballs. They're called extrinsic because they are going to originate outside the actual eyeballs, inside of the orbit, and they will insert on the white outer part of the eye, which is called the sclera. An interesting thing about these extrinsic eye muscles is that they are some of the fastest contracting and most precisely controlled skeletal muscles in the body. They can be divided into two groups. We have the four recti muscles, which are going to be the superior, the inferior, the lateral, and the medial rectus. And then we're going to have two that are oblique muscles, which are the superior and inferior obliques. With regards to function, since they will insert on the sclera, which is part of the eye, the superior rectus will therefore, when it contracts, it will cause elevation of the eye. So it will bring your eye up. However, it can also perform adduction, which means that it will bring it medially, as we can see from this arrow over here. Like the name says, the inferior rectus, it will insert on the inferior anterior part of the sclera, and when it contracts, it will mainly perform depression, but it can also perform adduction and lateral rotation, as we can see right over here. The medial rectus, it will insert medially on the sclera, like the name says, and when this muscle contracts, it will perform adduction. Therefore, it will bring it closer to the nose. The lateral rectus, it will insert on the lateral part of the sclera, and the main function will be abduction, so pulling it away from the nose. Now, I know we're not talking yet about nerves, but we will on the next module when we start to cover nervous system. So I just want to let you know over here which muscles are going to be innervated by which nerves. And when we cover cranial nerves, then you will be able to link the two again. So the lateral rectus is going to be the only muscle of the eye that will be innervated by its own nerve, which is called the abducens, which is exactly what it does. It abducts the eye. All other recti, which are the superior, the medial, and the inferior, will be innervated by what we call the ocular motor nerve. Then we're going to have the obliques. We have two obliques. We have the superior oblique, which is this one right over here. And then we have the inferior oblique, which is this one right over here. The superior oblique, it will originate on the sphenoid, and it will insert obliquely on the superior part of the sclera. And the inferior oblique, it will originate right over here on the maxilla, and it will insert on the lateral part of the sclera. Therefore, we can say that the superior oblique, it will depress the eye, and it will also abduct, as it will pull it in this direction, and it will also medially rotate the eye. And the inferior oblique will do the opposite. It will elevate the eye, it will abduct the eye as well, but it will rotate it laterally. These are just images of the extrinsic eye muscles on a superior view. This would be the medial side. Again, this is your medial side. This would be anterior. Here would be anterior. Therefore, here it's posterior. And here is posterior. You can see the superior rectus, the lateral rectus, and going towards the medial part would be your superior oblique. Same thing on the left image. Superior rectus, because this is medial, then this is your lateral rectus. Down over here would be your medial rectus, and the one that goes on an angle would be your superior oblique. Now it's important to add that the superior oblique held in place by a small tendon that's called the trochlea that will serve as a pulley. So when the muscle contracts, it will serve as a pulley to hold the muscle in place. And again, this tendon is called the trochlea. These are the models that you will see in the lab portion. The first thing that you need to know is that you need to search for the oblique muscle. The oblique will always point towards the medial side. So this would be your medial rectus. Up here would be your superior rectus. Down here is your inferior rectus. Again, this is the superior oblique. See how it's going on an angle? So this would be your superior rectus. The superior oblique is going towards the medial side. So this would be your medial rectus, your lateral rectus, your inferior rectus. On a superior view, superior oblique, superior rectus, lateral rectus, medial rectus. And down here we can see the inferior oblique coming in an oblique angle towards the midline of the body. So again, always search for the obliques, see where the obliques are going. They always go to the medial side. Therefore, you will know what's medial and what's lateral. If they're going on an angle, they're going to be the obliques. If they're going straight to the back, they will be the recti. Now we're moving on to the neck muscles, and there are two groups of muscles that are going to be associated with the anterior aspect of the neck, which are the suprahyoid muscles, and they're called suprahyoid because they're going to be located superior to the hyoid bone. Where is the hyoid bone? Right over here. And then the next group would be called the infrahyoid muscles, which receive this name because they're going to be located inferior to the hyoid bone. And both groups of muscles, they're important because they're going to stabilize the hyoid bone, as you can imagine, and it will also allow it to serve as this firm base of which the tongue can move. If you can remember from the axial skeleton, the hyoid bone is this floating bone that will not articulate with anything. So for it to be held in place, it needs to be attached to several muscles, and that's exactly what's happening here. The muscles that are going to be located above the hyoid bone, so the suprahyoid bone, they will pull the hyoid bone up, therefore they will elevate the hyoid bone. And these muscles are the digastric, the mylohyoid, and the stylohyoid. Notice how the digastric does not have the word hyoid on it. This means that it won't attach directly to the hyoid bone. There's like a little pulley of tendon that will hold it in place and swing it around. So there's going to be an anterior belly over here and a posterior belly that swings behind. Next, we have the mylohyoid. The mylohyoid, like the name says, mylo means mandible. Therefore, it will go from the mandible to the hyoid bone, and it will pull in this direction. Therefore, it will elevate the hyoid bone. And lastly, we have the stylohyoid, which, like the name says, stylo for styloid process, and it will be a muscle that will go from the hyoid bone all the way to the styloid process in the back. Remember, the styloid process is a bone feature of the temporal bone. So it will pull the hyoid bone again in this direction, pull it back. So it will elevate the hyoid bone. Then the infrahyoid muscles are the omohyoid and the sternohyoid. Omo means shoulder and sterno means sternum, right? So the omohyoid is this muscle right over here that swings around and goes from the shoulder or the clavicle all the way to the hyoid bone. And because it starts on the clavicle and inserts on the hyoid bone, it will pull the hyoid bone down. Same thing with the sternohyoid. So the sternohyoid will originate over here in the middle. It's a little bit hard over here. It will originate over here on the sternum and it will insert on the hyoid bone. Therefore, it will pull the hyoid bone down once it contracts. Here are just other images for us to see the same muscles, but in more details. This would be your temporal bone. The temporal bone has the styloid process, which is this process right over here. We can see highlighted over here, this tiny little thin muscle will be your stylohyoid. So it goes from the hyoid bone to the styloid process and it pulls in this direction. Therefore, it elevates the hyoid bone. The digastric here would be the anterior belly, and this would be your posterior belly. Same thing on this other image. So this would be your digastric swinging around over here. And this would be right in the middle, your sternohyoid. Your omohyoid is this one over here that continues to go around the clavicle bone. We do have another muscle here, which is the sternocleidomastoid, which we will cover in the next segment. Here on the lab model, we can see the digastric. The anterior belly would be here. This would be the tendon loop, and it would go back. On this image that's a little bit larger, we can see again the anterior belly, the loop, and this one over here would be the digastric. This would be your mylohyoid that connects the mandible to the hyoid bone. This would be your hyoid bone right over here. Again, hyoid bone, the mylohyoid, all of this would be your mylohyoid. And then the stylohyoid is this very thin one over here that goes behind. So this would be your stylohyoid. Notice how there's a big gland over here. This gland is called the submandibular gland. Makes sense. It's a salivary gland below the mandible. So submandibular salivary gland. And the stylohyoid, it is closer to the submandibular salivary gland than the digastric. These two can be a little bit confusing on the model, so make sure that you pay attention. Next, we're going to have the muscles that are located also on the neck, but now they will move the head instead of moving the hyoid bone. There are two different groups. We have the ones that are located laterally and the ones that are located posteriorly. The ones that are located laterally, they will function to flex the neck, and the ones that are located posteriorly, they will either extend the neck or hyperextend the neck. So extend the neck, if we are in an anatomical position, which is this image, for example, over here, our neck is already extended. But when we flex the neck, meaning that we will decrease the angle anteriorly on the neck, and we want to move the neck back to anatomical position, we're going to be extending the neck. However, if we pull our head further back, then that will be hyperextension. There are two groups of muscles that will function mainly to flex the neck. These are going to be the sternocleidomastoid, and like the name said, sterno, it will have a belly on the sternum. Cleido, it will have a belly on the clavicle, and mastoid for mastoid process. So this muscle will originate down here and will insert on the mastoid process. Therefore, it will pull your head down and flex anteriorly. The other group of muscles are what we call the scalenes, And you can see the scalenes right over here. There are 3 scalenes. We have the anterior, the medial, and the posterior scalenes. And we will be able to see them better on the next slide. But they will also flex the neck. And posteriorly, we have 2 main groups. We have this huge one over here that's called the trapezius, or the traps, like you guys like to call it. So it will originate down here on the vertebral column part of it, and it will insert on the occipital bone. Therefore, when it contracts, it pulls your head further back. And then the splenius capitis are these muscles that are located deep to the trapezius, and when it contracts, it will also pull your head back. These images are to show you these muscles in a better view. This would be your sternal part, your cladal part, and then they would come together at the mastoid process. Because they insert on the mastoid process, they pull in this direction, therefore they flex the neck. Here we have the scalenes. Like I said, there are 3 scalenes, the anterior, the middle, and the posterior scalenes. And these will also flex the neck. Posteriorly, we have the trapezius, which is this huge muscle over here, and then the splenius capitis, which is going to be deeper. Both of these will pull in this direction, therefore they will extend the head at the neck. Now don't get the trapezius confused with the trapezium, which is one of the carpal bones. So it's just one letter different, but one is a muscle and one is a bone. In our lab model, back here would be the trapezius, so all of this is your trapezius. These would be your scalenes. Right over here are your scalenes. This one over here is going to be your splenius capitis, and this big one over here would be your sternocleidomastoid.